Somewhere off the Egyptian coast west of Alexandria, a diver kicks downward through murky water and stops. In front of them, half buried in sediment on the sea floor, is something that should not be there. Limestone blocks, arranged with unmistakable deliberateness. Pottery sherds, amphorae, and beyond them, the suggestion of a passage, a cut through bedrock, running in a direction that implies intent, engineering, a destination somebody once had in mind. This is not a shipwreck. This is not a collapsed jetty. This is, as far as the dive team can tell, a tunnel. Between 2022 and 2023, a Dominican-Egyptian research team descended on the submerged fringes of Taposiris Magna, a Greco-Roman temple site on the Egyptian coast, and began documenting what they found on the seabed. What emerged from their footage and surveys was the underwater reach of a structure that, on land, had already been astonishing. A tunnel aqueduct cut through solid bedrock, running for 1,305 metres from Lake Maritima toward the Mediterranean Sea. Scholars who examined its geometry called it, with no apparent exaggeration, a geometric miracle. It bore a striking resemblance to the Eupalinos tunnel on Samos, an engineering marvel from the 6th century BC, and appeared to be a deliberate Greco-Roman replica of that earlier feat. The divers were not looking at a curiosity. They were looking at one of the longest submerged ancient passages ever recorded in the Mediterranean. And nobody can say with confidence what it was for. That last sentence is not rhetorical modesty. It is the actual state of the evidence. The tunnel's dating, whether it belongs to the Ptolemaic period or a later Roman phase, remains contested. The inscriptions recovered from the site are still under analysis. The function is genuinely unresolved. Was it an aqueduct, moving fresh water from the lake to a coastal settlement? Was it a harbour access route, allowing boats or cargo to move between the lake system and the sea without exposure to open water? Was it something else entirely, a passage designed to be invisible, to keep something or someone hidden from eyes on the surface? Every one of those interpretations has its advocates. None has been confirmed. That ambiguity is uncomfortable, because we are trained to expect that excavation resolves questions. Here it multiplies them, and that discomfort is exactly where this investigation begins, because Taposiris Magna is not an isolated anomaly. Pull back from that single dive site and look at the broader Mediterranean, and you start to notice a pattern, or at least the outline of one. Ancient writers kept mentioning passages they described as closed, restricted, or simply unavailable to ordinary sailors. Strabo wrote of harbour arrangements that controlled access. Pliny described engineering works whose details resisted easy summary. Josephus documented the harbour of Caesarea Maritima in terms that implied a complexity beneath the waterline that visitors on the surface could not fully perceive. These are not the descriptions of writers inventing colour. They are, in several cases, the observations of men who visited the sites and tried to make sense of what they saw. What they saw, in many cases, is now underwater. Sea level changes, coastal subsidence, and 2 millennia of wave action have placed some of the Mediterranean's most significant ancient harbour infrastructure below the surface, out of reach of traditional archaeology and outside the frame of our historical understanding. Caesarea Maritima's harbour of Sebastos, the great Roman port on the Levantine coast, has submerged breakwaters sitting at depths of 6 to 9 metres, along with a complex of architectural elements that recent high-resolution survey work in 2025 only now began to map in 3 dimensions. The entrance channel, the breakwater alignments, the hidden geometry of a harbour that served one of the ancient world's busiest coastlines. Modern underwater archaeology has tools that previous generations could not have imagined. Multi-beam echo-sounder systems, structure from motion photogrammetry, sub-bottom profiling, remotely operated vehicles. Together they are turning mystery into measurable data. producing detailed three-dimensional models of structures that were functionally invisible to scholars a generation ago. What those models are beginning to show is not a handful of isolated discoveries. They are showing what may be a widespread, poorly documented tradition of subterranean and submerged maritime engineering, stretching across the Greek, Egyptian, and Roman worlds. Whether that tradition constitutes a network of genuinely secret passages, or whether the word secret is a modern romance draped over practical ancient engineering, is precisely the question this investigation will press. The legend and the archaeology are not the same thing, and treating them as interchangeable does justice to neither. So this is what follows. We will go inside the Taposiris Magna tunnel as far as the evidence allows. We will look at Caesarea and what its submerged harbour reveals about the engineering ambitions of Rome. We will weigh what the ancient texts actually say against what the sonar data actually shows. We will consider who would have built hidden maritime infrastructure and why and for whom. And we will be honest about how much remains genuinely unknown. The divers found something impossible. Now we try to figure out what it is. Before we go any further into specific sites and what the divers found there, we need to slow down and deal with the terminology problem, because the phrase underwater tunnel does the kind of work that sounds precise but is actually doing very little. It conjures something specific, a deliberate passage, roofed and walled, dark and enclosed, engineered for a purpose. But the archaeological reality beneath the Mediterranean is far messier than that image suggests, and if we do not draw some clear distinctions early, we risk spending the rest of this investigation arguing past ourselves. So let us define our terms, and let us be honest about where the definitions get uncomfortable. A true tunnel, in the archaeological sense, is a deliberately excavated conduit, with a continuous roof and walls, built to allow something, water, people, cargo, boats, to pass through it from one point to another. It is engineered enclosure. It has intention written into its geometry. The Eupalinos tunnel on Samos, cut through a mountain in the 6th century BC, fits this definition without controversy. It is 1,036 metres long, has measurable wall surfaces, tool marks in the rock, and a documented function moving water to the city of Samos. When we call it a tunnel, there's nothing slippery about the word. The Taposiris Magna structure, which appears to be a deliberate Greco-Roman replica of that Samian engineering feat, reaches 1,305 metres and was, at least in part, designed to transport water from Lake Mariut toward the Mediterranean coast. Whether the submerged portion of it constitutes a navigable tunnel in any meaningful sense is precisely where the debate begins. Then there are aqueducts. An aqueduct is a water-carrying channel. It may descend below sea level, it may run through bedrock, it may be spectacular, but it is not designed for ship traffic. Aqueducts typically have a gentle slope calibrated for water flow, a rectangular cross-section that manages hydraulic pressure, and dimensions that do not accommodate the draft of any vessel larger than a small rowing skiff. The distinction matters enormously here, because the Taposiris Magna structure is officially described in the scholarly literature as a tunnel aqueduct, a hyphenated term that already signals some ambiguity about which category it belongs to. If it was built to move water, it was not built to move boats, and calling it a maritime passage requires evidence beyond its existence. Harbour channels are something else again. These are the navigable lanes between breakwaters, the open water cuts or dredged passages that allow ships to enter a port. They have no ceiling, they are not enclosed, they are gaps, not tubes. What makes them relevant to our story is that they can be wide and deep and deliberate. The harbour entrance at Caesarea Maritima, for instance, remained, in the words of recent survey work, wide and deep enough for the passage of vessels, even after 2,000 years of submersion and sediment accumulation, but they are structurally the opposite of a tunnel. Light reaches them. Sailors could see the sky above them. Calling them tunnels, however dramatically satisfying, is a misuse of the word. Then there are submerged corridors, partially roofed or tunnel-like spaces that were originally natural sea caves or rock-cut galleries, later adapted for human purposes. These are genuinely ambiguous. Ancient coastal engineers were opportunistic. If a cave offered natural shelter or a natural channel offered a shortcut, they would line it with masonry, regularize its cross-section, and integrate it into harbour infrastructure. The key distinguishing features that archaeologists look for here are tool marks on the rock surfaces, masonry lining that implies deliberate finishing, and consistent cross-section that suggests intentional shaping rather than random erosion. Without those features, a corridor that looks impressive on a dive might be nothing more than geology doing what geology does. And that brings us to the category that causes the most confusion in popular accounts of Mediterranean underwater archaeology: collapsed breakwaters. Ancient harbours were built with enormous stone walls extending into the sea. The northern breakwater at Caesarea is documented as a structure of large-scale hewn stone blocks, while the southern breakwater in the same harbour is described as an extensive scatter of rubble, the result of 2,000 years of wave action and structural decay. When those walls break apart and sections collapse inward or outward, they can create gaps, channels, and partially covered spaces that look, to a diver sweeping a torch beam through murky water, remarkably like tunnel openings. They are not. They are the remains of solid construction that has failed. The geometry that seems meaningful is the geometry of destruction, not intention. This is not a pedantic distinction. It is the core classification debate shaping everything that follows in this investigation. Because a significant portion of the structures that have been described in news reports, in preliminary survey notes, and occasionally in academic literature, as secret tunnels or hidden passages are, when examined rigorously, more likely to be one of these other categories. The label is attractive. Secret tunnel tells a story that harbour channel does not. It implies agency, concealment, the deliberate creation of something hidden from the world above. Archaeologically, it is slippery in a way that makes serious researchers visibly uncomfortable when the term gets applied too quickly. So what would it actually take to claim that an underwater structure was a navigable tunnel used by ancient sailors? Scholars working in this field have proposed a set of evidence standards, and they are worth spelling out explicitly. First, you would need to demonstrate engineered enclosure, a roof and sidewalls that were deliberately constructed and not merely the product of natural rock formation or structural collapse. Second, you would need dimensions sufficient for ancient ship draft. In practical terms, a depth of more than 2 meters and a width of more than 3 meters to accommodate even a modest ancient vessel. Third, you would need construction marks, tool traces, masonry courses, mortar, or some other sign of intentional building rather than natural formation. And fourth, you would need dating evidence consistent with the known phases of whatever harbour or settlement the structure is associated with. Satisfy all 4, and you have a case. Satisfy 2 or 3, and you have an intriguing hypothesis. Satisfy 1, or rely primarily on the visual impression a diver gets passing through a gap in collapsed stonework, and you have a story, but not yet a finding. Natural processes complicate this further in ways that are easy to underestimate. The Mediterranean coast has subsided in many places by several meters over the last 2,000 years, partly through tectonic activity and partly through the sheer weight of ancient construction on soft coastal sediments. Structures that were built on dry land or at the waterline now sit on the seabed, and the seafloor itself has been reshaped repeatedly by storms, sediment transport and biological activity. A channel that appears to run through bedrock may be a natural fault line that was never touched by human hands. A roofed passage that seems deliberately enclosed may have acquired its roof when a wall collapsed across it centuries after the Romans left. Disentangling the artificial from the natural and the original from the subsequent requires systematic survey rather than a single dive and a compelling photograph. None of this means that the structures this investigation examines are unimportant, or that the search for ancient underwater maritime passages is misguided. It means the opposite. The precision of the distinction is what makes a genuine discovery genuinely significant. If a structure at Taposiris Magna or Caesarea, or anywhere else in the Mediterranean basin, eventually satisfies all four of those evidence criteria: enclosure, adequate dimensions, construction marks, and consistent dating, then what we have is not just a tunnel. What we have is evidence that ancient engineers deliberately built navigable submerged infrastructure for purposes they considered important enough to justify extraordinary effort. That is a major historical finding. It deserves to be established on evidence that matches its weight. For now, the honest position is this. Some of what we're going to examine in the following sections are confirmed ancient structures whose exact function remains debated. Some are structures that appear tunnel-like under survey conditions but have not yet been fully classified. Some are harbour passages that were certainly used by sailors but were not enclosed and not, in any strict sense, tunnels. And some, the most tantalising category, are structures where the evidence is genuinely uncertain and where the next round of survey work could move them into or out of the tunnel classification. Understanding which category a structure belongs to and why that category matters is not a distraction from the investigation. It is the investigation. Because the question is not simply whether there are things underwater that look like tunnels. There clearly are. The question is what ancient sailors actually knew, used, and moved through beneath the surface of the Mediterranean. And for that question, the difference between a true tunnel and a collapsed breakwater is everything. With those classification questions in mind, we can now step back and look at the broader canvas, because the Mediterranean seafloor is not a uniform graveyard of isolated wrecks and collapsed walls. It is something more structured than that. It is, in the language archaeologists have begun using with increasing seriousness, an archive, a physical record of ancient logistics, commercial infrastructure, and engineering ambition that has been accumulating in the dark for 2,000 years or more. Understanding why so much of it ended up underwater and why it stayed invisible for so long is essential before we can make sense of any specific site. Start with the coast itself. The shoreline that ancient sailors knew does not exist anymore, not in any simple sense. The Mediterranean basin has been geologically restless throughout human history, and the combination of tectonic movement, sediment loading, and the long tail of post-glacial sea level rise has shifted the relationship between land and water in ways that are easy to understate. At Alexandria, integrated seismic and geomorphological work on the ancient royal harbour documents more than 2 meters of submergence, with the harbour floor now lying between 3 and 14 meters below the modern sea surface. That is not a uniform drowning. The variation across that depth range reflects the uneven effects of local subsidence, structural settlement, and catastrophic events layered on top of each other over centuries. The city that Cleopatra's engineers built at the waterline is not at the waterline anymore. It is beneath it, and the further down the rubble sits, the older the event that put it there. At Naples, the picture is just as instructive. Multi-proxy reconstructions of relative sea level in the ancient harbour document a subsidence rate of roughly 1.5 millimeters per year between approximately 200 BC and the start of the Common Era, slowing to somewhere between 0.5 millimeter and 1 millimeter per year in the Roman period. Those numbers sound small until you apply them across the full span of ancient and medieval history. Over 500 years at even the lower rate, you're looking at a vertical shift of close to 0.5 meter for the harbour infrastructure alone. enough to transform a functioning quayside into a submerged obstacle, and to silently push vessels toward anchorage further offshore. The scholars who produced this work are careful to note that the exact figures carry an uncertainty of around half a metre, depending on local tectonic conditions, which is worth remembering. But the direction of change is not in doubt. Along the Israeli coast at Caesarea, the pattern repeats. The breakwaters of the Roman harbour of Sebastos, the enormous construction project that Herod the Great completed around 10 BC, now sit in 6 to 9 metres of water. The submergence there is the cumulative product of the same forces: land level subsidence, eustatic sea level rise, and structural settlement of the harbour walls themselves into the soft sandy seafloor on which they were founded. The southern breakwater at Caesarea shows what happens when those processes interact with storm energy. Unconsolidated sandy foundations, 2,000 years of wave action, and the sheer mass of stone blocks without adequate bedrock support produced what survey work describes as an extensive scatter of rubble. A wall that was once a coherent engineering feature reduced to fragments distributed across the sea floor in a pattern that, from above, yields very little useful information without high-resolution acoustic imaging. That storm-driven destruction is worth dwelling on, because it is not only a slow process. The 365 CE tsunami, triggered by a massive earthquake along the eastern Mediterranean subduction zone, produced high-energy wave events that researchers have traced through sediment deposits at multiple sites from Alexandria to Caesarea. Direct evidence from offshore surveys shows that these events were capable of scouring sediment from some areas while depositing it heavily in others, burying harbour entrances under several metres of material in hours, and relocating stone blocks that had sat undisturbed for centuries. When you're trying to understand why a harbour installation that Julius Caesar or Cleopatra or Herod once relied upon has been invisible to modern eyes until the last decade or two, the 365 CE tsunami is part of the answer. The sea did not merely rise quietly. At certain moments it arrived with violence and rearranged the architecture accordingly. All of this environmental change does something that is easy to overlook. It does not merely destroy ancient harbour works. It preserves them in a particular and inconvenient way. Burial under sediment, whether from gradual accretion or storm deposition, is actually what keeps ancient masonry intact over millennia. Stone exposed to wave action and bioerosion at the water surface degrades relatively quickly. Stone buried under 2 or 3 metres of sand and silt in a low-oxygen environment can survive remarkably well. The submerged installations at Caesarea, breakwaters, quay faces, the entrance channel descending from 8.5 metres depth up to 2 and 8 metres, have retained enough physical coherence that high-resolution three-dimensional photogrammetry conducted in recent years could map not just their gross dimensions but the details of their construction, including the spatial relationships between individual blocks and the geometry of the entrance passage itself. What emerges from that survey is not just a ruin, it is a record of how cargo traffic and vessel movement were organised in a major Roman commercial harbour. The sea floor at Caesarea preserves the logistics of empire, not merely its rubble. The same principle applies at Naples, where buried harbour basins and stone block remnants document the scale of commercial throughput, and the gradual silting that eventually forced vessels to discharge cargo offshore rather than at the quayside, a detail that tells you something specific about how trade routes adapted to infrastructure decay in real time. The sea floor, in other words, is not just the place where ancient things fell. It is the place where the evidence of ancient decision-making accumulated, undisturbed, while the land above it was built over, ploughed, looted and reinterpreted a dozen times. And that leads directly to the question of invisibility. If these structures are so well preserved, why did we not know about them sooner? The answer is partly sediment depth and partly resolution. Progressive sediment accretion across harbour floors can amount to several metres over 2 millennia, burying entrances and auxiliary channels entirely. The low-relief concrete walls and narrow passageways that characterise Roman harbour construction sit close to the sea floor even where they are exposed, making them almost indistinguishable in conventional underwater survey from natural rock features or undifferentiated rubble. Early archaeological diving, which relied on visual inspection and physical measurement, simply could not detect the difference at the resolution required. The structures were there. The methods were not adequate to find them. That has changed, and changed rapidly. But the point for this moment in the investigation is not the technology. That comes later. The point is that the Mediterranean seafloor contains a systematic record of ancient maritime infrastructure that has been accumulating quietly since harbours first subsided, tsunamis first struck, and sediment first settled. The question of whether any part of that infrastructure includes deliberate navigable tunnels cannot be separated from this broader environmental story, because the same processes that buried a harbour entrance also concealed whatever was built inside it, and the same methods that are now recovering breakwaters and quay faces are beginning slowly to reveal what lies further in. So we have established that the seafloor holds a systematic record of ancient maritime infrastructure, much of it buried and only recently becoming visible. But before we examine specific sites in detail, we need to ask a prior question, one that shapes how seriously we should take the possibility of deliberate engineered underwater passages at all. Was ancient engineering actually capable of building them? And not just capable in a theoretical sense, but capable in the precise, sustained, logistically demanding way that submerged tunnel construction would require? The answer, it turns out, is not a matter of speculation. It is a matter of record. Begin with the Greeks, because the Greeks left us a structure that has never stopped astonishing the engineers who study it. On the island of Samos, in the 6th century BC, a man named Eupalinos of Megara oversaw the construction of a tunnel designed to carry fresh water from a spring on one side of a mountain to the city on the other. The tunnel runs for just over 1,000 metres, 1,036 metres to be reasonably precise, directly through solid limestone bedrock. That alone would be a remarkable feat. But what makes the Eupalinos tunnel genuinely extraordinary is how it was built. Not from one end, from both ends simultaneously. 2 separate teams of workers started at opposite faces of the mountain and cut toward each other through rock they could not see through, guided by geometric calculations made with instruments that were rudimentary by any modern standard. When the 2 teams finally broke through and met somewhere in the middle, they were off by only a few decimeters, not meters, decimeters. In the 6th century BC, without laser alignment, without GPS, without any of the measurement tools we now consider basic, ancient engineers achieved a precision that remained unmatched in civilian construction for centuries. The Eupalinos tunnel is not just an impressive historical artifact, it is a benchmark. It tells us that the ancient world had the geometric knowledge, the organizational capacity, and the practical skill to execute long underground passages with genuine accuracy and for explicitly functional purposes. This was not monumental construction built to impress. It was infrastructure built to work, to move water reliably through a mountain under conditions where surface exposure would have made the route vulnerable to enemies. The strategic dimension was inseparable from the engineering. That strategic dimension only deepened as Greek practice fed into Roman engineering culture, which scaled underground construction to levels that remain almost difficult to absorb. The Gadara Aqueduct in the Decapolis, Roman period construction serving cities in what is now Jordan, includes a subterranean tunnel section running for more than 106 kilometres. That is not a misprint. more than 100 kilometres of underground waterway, the longest known tunnel from the entire classical period, executed with the same logic that animated Eupalinos on Samos, but at a scale that reflects the resources and organisational reach of empire. When you hold that fact in mind, the idea that Roman engineers might have incorporated tunnel sections into harbour works or coastal infrastructure becomes not exotic, but almost expected. Underground construction was a mature technology. It had been applied across the Greek and Roman worlds for half a millennium before the harbours we are investigating here were even built. The Egyptian context adds another dimension. Egypt's engineering tradition was older than either Greece or Rome, and when Greek-influenced rulers took control of Egypt following Alexander the Great's conquests, they inherited a culture with deep institutional knowledge of large-scale hydraulic construction, canals, underground chambers, water management systems cut through rock and sand across a landscape defined by the relationship between water and land. The Ptolemaic and later Greco-Roman builders who worked in Egypt did not start from nothing. They worked within an accumulated tradition, and, as the evidence from at least one specific site suggests, they sometimes explicitly referenced earlier masterworks as models for what they were trying to achieve. Which brings us to a structure that will feature prominently in what follows, the tunnel aqueduct discovered at Taposiris Magna, west of Alexandria, documented by researchers working between 2022 and 2026. The excavators described what they found in striking terms. The Taposiris Magna tunnel runs for approximately 1,305 metres, that is 270 metres longer than the Eupalinos tunnel on Samos, was cut to a depth of roughly 15 metres below the modern ground surface, and runs from the ancient Lake Mariut toward the Mediterranean coast, with part of it now lying on the seabed. The discoverers characterised it explicitly as an exact replica of the Eupalinos tunnel. Same design logic, same construction method, same functional ambition, executed in a different material and geological context, in a different century, but in conscious dialogue with that 6th century Greek original. Whether the characterisation holds up in every technical detail is something scholars will continue to debate. But the directional claim is important. Ancient builders in the Greco-Roman Mediterranean were not working in isolation from each other. They knew their precedents, they studied earlier engineering achievements and drew on them when designing new projects. This matters enormously for how we assess the plausibility of hidden maritime infrastructure. Plausibility is not the same as proof, a distinction that needs to be kept sharp throughout this investigation. What the engineering tradition establishes is that the idea of deliberate, functional, precisely constructed underground passages serving practical and strategic goals in the ancient Mediterranean world is not the product of modern imagination. It is supported by the actual archaeological and historical record of what ancient engineers demonstrably built and demonstrably could build. The Eupalinos tunnel proves long underground passages were achievable with ancient technology. The Gadara Aqueduct proves that Roman engineering could sustain such construction across enormous distances. Herod's harbour at Caesarea, completed around 10 BC, proves that Roman builders could pour hydraulic concrete into wooden forms underwater at depths of 6 to 9 metres and produce durable submerged structures. A North Breakwater alone 500 metres long sitting on the sea floor, still coherent enough 2,000 years later to be mapped in 3 dimensions by modern survey equipment. The tradition of sophisticated subterranean and subaquatic engineering is not hypothetical. It is documented across multiple cultures, multiple centuries, and multiple types of construction. What is not yet established, and this is where honest investigation has to plant its flag, is whether any specific structure in the Mediterranean represents a deliberate, navigable, purpose-built tunnel serving maritime traffic in the way the most striking claims about underwater passages suggest. The engineering tradition makes that possibility technically credible. It does not make it confirmed. Every ancient culture that built the Eupalinos tunnel or the Caesarea harbour also built structures that have been misidentified, misclassified, or misunderstood by later investigators, sometimes for generations. The tradition behind the mystery is real. The mystery itself remains open. What we need now is specific evidence. And the most compelling candidate, the place where tunnel, sea, and unanswered questions come together most sharply, is Taposiris Magna itself. Taposiris Magna sits on a limestone ridge about 45 kilometres west of Alexandria, overlooking the narrow strip of land between Lake Marietta and the open Mediterranean. To modern visitors, it looks like a partially excavated ruin, a Ptolemaic temple precinct with a lighthouse-style tower, scattered architectural debris, and the kind of quiet that accumulates around places that were once important and have since been largely forgotten. But what the site looks like on the surface is increasingly irrelevant. The significant discoveries at Taposiris Magna are happening underground and underwater. The tunnel aqueduct announced in November 2022 by the Dominican Egyptian archaeological team runs for 1,305 metres, approximately 4,300 feet, hewn through sandstone at a depth of roughly 15 metres below the modern surface. To put that length in context, the Eupalinos tunnel on Samos, the 6th century BC engineering achievement that the excavators explicitly invoked as a comparison, runs 1,036 metres. The Taposiris tunnel is 270 metres longer. When the Egyptian Ministry of Tourism characterised the find as a Greco-Roman replica of the Eupalinos design, that was not casual language. The structural logic, the construction approach, the ambition to drive a long underground passage through rock for functional purposes, all of it echoes the Samian original. The builders appear to have known what they were referencing. Whether every technical detail holds up under ongoing scholarly scrutiny is a question that remains open, but the directional parallel is striking enough that researchers on the project used it as a primary frame of reference when presenting the discovery. The route the tunnel follows is what makes the engineering decision so consequential. It runs westward from Lake Marietta, the inland freshwater lake that in antiquity connected to Alexandria's canal and harbour network, toward the Mediterranean coast. This is not an arbitrary alignment. It creates a direct engineered link between the interior water system and the sea, passing beneath the Taposiris Magna temple complex along the way. What sits at each end of that link, and what moved through the passage between them, is precisely what the site's researchers have been working to establish. That effort has been complicated by the condition of the tunnel's seaward end. Part of the structure now lies on the seabed. The precise extent of the submerged segment has not been fully measured. The underwater archaeology is still in progress, and scholars differ on its total length. But the existence of the submerged portion has been confirmed through direct survey. In the initial 2022 fieldwork, divers from the excavation team identified limestone blocks, pottery and amphorae lying on the seafloor at the relevant location. These were not random debris. They were architectural elements and cargo indicators consistent with a structure that had once continued where the seafloor now is, and that had seen active use before, whatever coastal subsidence or sea level change submerged it. Between 2022 and 2026, subsequent fieldwork pushed the visualization of the underwater segment considerably further. Diver-borne photogrammetry, multi-beam sonar, and three-dimensional modelling were applied to the submerged section, including a passage the team designated as the Salam 5 area, where divers followed the tunnel to a series of stone structures that have not yet been fully characterized. This is painstaking work. Underwater documentation at these depths, with this level of structural complexity, does not yield quick answers. but the result has been a progressively more detailed picture of a structure that extends from a functioning ancient water system on the inland side through a major religious administrative complex and continues into the sea in a way that has no fully agreed explanation. The Greco-Roman character of the tunnel is reinforced by more than its comparison to Eupalinos. Inscriptions found during the excavation are still under analysis, but architectural details visible both in the land-based and underwater portions are consistent with construction during the broad period running from the Ptolemaic foundation of Alexandria in 331 BC through the Roman administration of Egypt that followed, a span of several centuries during which Taposiris Magna was an active and apparently significant site. The precise chronology awaits the completed inscription analysis and may, when it arrives, either narrow the date range considerably or introduce new complications. Dating in underwater archaeology is rarely clean. What the site reignited, almost immediately after the 2022 announcement, was a set of questions that the engineering tradition we discussed earlier makes impossible to dismiss as fanciful. If this passage runs from a major ancient water network toward the Mediterranean, terminating in structures currently on the seabed, and if its builders were operating in conscious dialogue with a tradition of sophisticated underground hydraulic engineering, then what exactly was it for? The answer that sits most comfortably with the structure's physical form is that it functioned as an aqueduct, a conduit for fresh water, moving from the lake system outward, possibly to supply ships in an adjacent harbour or to serve coastal facilities now submerged. That is the most parsimonious interpretation, and remains the working hypothesis for a significant portion of the research team. But the physical facts resist that as a complete explanation. The depth of the passage, 15 metres below surface, exceeds what most aqueduct systems required. The route's specific alignment with the coastline and the presence of what divers described as a series of stone structures at the seaward end rather than a simple outlet opens the question of whether the tunnel served additional functions or functions different from pure water conveyance that the structure's current classification does not capture. Scholars have variously proposed harbour access, secure cargo movement, ritual processional use connected to the temple precinct above, and mixed-use conduits serving several purposes simultaneously. None of these interpretations has been confirmed, none has been ruled out. It is worth being direct about where that leaves us. Taposiris Magna has produced the most detailed physical evidence we currently have for an ancient underwater tunnel aqueduct in the Mediterranean world. The structure is real, its length is documented, its route has been traced. Divers have followed part of it on the seabed and produced three-dimensional maps of what they found there. This is not speculation, it is archaeological fieldwork generating tangible data. What remains genuinely uncertain is function, what the ancient builders intended this passage to do, and whether its submerged terminus represents a harbour access point, a water outlet, or something that does not fit cleanly into either category. That uncertainty is precisely what gives the site its investigative energy. Taposiris Magna was already generating significant scholarly interest as a possible location connected to Cleopatra's burial, for reasons that have nothing to do with the tunnel. The discovery of a 1,305-metre underground passage with a submerged seaward end at a site already associated with some of antiquity's most consequential figures did not calm that interest. It amplified it considerably, and in ways that are not always easy to separate from the more sober question of what the engineering actually tells us about ancient maritime infrastructure. That separation matters, and it is worth making carefully. So the question is on the table, and it deserves a serious examination. What exactly are we looking at when we look at the Taposiris Magna tunnel? Two broad interpretations have emerged from the scholarly work on the site, and they are not merely different emphases within the same basic story. They are genuinely competing readings of the same physical evidence, and the gap between them matters for how we understand ancient maritime infrastructure across the entire Mediterranean. Start with the aqueduct interpretation, because it carries the weight of comparative context and engineering logic. Marie-Françoise Boussac and the French-Egyptian research programme on water management at Taposiris Magna have framed the tunnel within a broader documented system for distributing water from Lake Mahut to the temple complex and its surrounding urban area. This is not a speculative framework. It draws on years of survey work showing how ancient settlements along the Mariot shoreline were systematically supplied with fresh water through engineered channels, cisterns, and conduits. The tunnel, in this reading, is the most ambitious element of a practical hydraulic network, designed to move water from the lake to facilities closer to the coast, possibly including a harbour where ships needed resupply. The comparison to the Eupalinos tunnel on Samos supports this interpretation directly. The 6th century BC Eupalinos structure was built as a water supply aqueduct, cutting 1,036 metres through limestone to bring a reliable freshwater source to the city of Samos. When the Egyptian Ministry of Tourism described the Taposiris Magna tunnel as a Greco-Roman replica of that design, the word replica was carrying specific meaning. It pointed to an engineering tradition where long underground passages served defined hydraulic functions. Aqueducts of this type are documented throughout the Greek and Roman worlds. The structural logic of the Taposiris passage, in terms of its cut stone construction, its gradient and its connection to the lake system, fits that tradition without requiring any additional hypothesis about secret transport or covert access. For researchers committed to parsimony, that is a powerful argument. The simplest explanation consistent with the physical evidence is that this was water infrastructure, built by engineers who knew exactly what they were doing and had clear historical models to follow. Then there is the other reading. Kathleen Martinez, the Dominican archaeologist who has led excavations at Taposiris Magna for nearly 2 decades, and explorer Bob Ballard have pointed to a different cluster of evidence when interpreting the tunnel's function. The passage runs approximately 4,300 feet in a direction oriented directly toward the sea. The seaward terminus, as documented by divers, includes not a simple outlet channel, but a series of stone structures, including what the excavation team described as a polished floor, and the surrounding seafloor in that area yielded anchors and amphora fragments consistent with organised maritime activity, not just debris from a collapsed water outlet. In Martinez's interpretation, these are indicators of a submerged port complex, and the tunnel connects the temple precinct to that port in a way that goes beyond freshwater supply. A conduit of this depth, this length, and this apparent structural elaboration at its seaward end, the argument runs, was designed to move more than water. What that more might be is where interpretation opens into territory that is genuinely difficult to pin down with current evidence. The presence of anchors and amphorae is consistent with a working harbour, but working harbours accumulate debris from many activities over long periods, and artefacts on a seafloor do not by themselves establish that a nearby tunnel was used for cargo transport rather than water distribution. The polished floor is a more distinctive detail. Polished surfaces in ancient passages often indicate sustained foot or wheel traffic, of a kind associated with transport rather than hydraulic engineering. But this element of the survey has not yet been fully published, in a form that allows independent scholars to evaluate the claim in detail. This is where the dating question becomes critical. The tunnel is broadly assigned to the Greco-Roman period, which spans from roughly 332 BC, the Macedonian conquest of Egypt under Alexander, through 395 AD, when the Roman Empire divided. That is a range of over 7 centuries, and it encompasses profoundly different political, economic and religious context for the site. if the tunnel dates to the early Ptolemaic period, around 280 BC, when the temple at Taposiris Magna was founded, then it was built under rulers who were simultaneously constructing the great lighthouse and library at Alexandria, developing canal networks across the delta, and managing one of the ancient world's most sophisticated maritime trading systems. A tunnel connecting a major religious site to the coast, in that context, carries one set of meanings. If it dates to the later Roman period, the context shifts considerably. The inscriptions on the tunnel walls are the most direct potential source of dating evidence, and they are still being analysed. What those inscriptions contain, whether they are dedications, technical notations, graffiti from construction workers, or something else entirely, could revise both the functional interpretation and the chronological assignment in ways that neither camp in the current debate can fully anticipate. This is not a hedge or an evasion. It is the actual state of the evidence. Epigraphic analysis of inscriptions from underwater and underground contexts takes time and requires specialist expertise, and the preliminary results from Taposiris Magna have not yet been published in a form that settles the interpretation. When they are, the story may look significantly different, or the inscriptions may be ambiguous enough to sustain the existing disagreement in a new form. What the Taposiris Magna tunnel has become, then, is something that archaeological sites occasionally produce and rarely resolve quickly. A single structure that functions as a battleground between evidence and imagination. The evidence is real. The tunnel exists, its length is documented, its route has been traced, its underwater extension has been directly surveyed. No one disputes the physical existence of what was found. What is disputed is the meaning of that physical existence, and the dispute runs through questions of function, chronology, and the interpretive weight we assign to engineering parallels versus artifact assemblages versus structural details that have not yet been fully published. The tension between evidence and imagination is not a failure of the investigation. It is what investigations look like at their active frontier. The engineers who cut 1,305 metres through bedrock and extended that cut into the sea were doing something deliberate and consequential. They made choices about depth, alignment, and terminal structures that have meaning, even if we have not yet fully read that meaning. The aqueduct hypothesis is coherent, the harbour access hypothesis is compelling, and the possibility that a structure built across several generations of ancient construction served purposes that do not map cleanly onto either modern category is one that archaeologists working in the region take seriously. What tips the balance, if anything ultimately does, will not be a single dramatic find. It will be the accumulation of precisely dated material from the tunnel's stratigraphy, the completed reading of those wall inscriptions, and the full three-dimensional publication of the underwater terminus. Until then, the Taposiris Magna tunnel remains what it genuinely is. A remarkable piece of ancient engineering whose builders knew exactly what they intended, and whose purpose we are still working to understand. There is a pattern worth examining here, and it has less to do with engineering than with storytelling. Whenever an incomplete archaeological find sits near the edge of what evidence can confirm, it tends to attract a specific kind of narrative gravity. The more famous the associated historical figure, the stronger that pull. And few figures in the ancient world generate narrative pull quite like Cleopatra VII. The connection between the Taposiris Magna tunnel and Cleopatra did not emerge from a single reckless claim. It grew from a genuine accumulation of suggestive details at the site. Underwater surveys in the waters near the tunnel's seaward terminus recovered amphorae, anchors, and dozens of Ptolemaic-era coins, several of them bearing Cleopatra's portrait. Those coins are real. The amphorae are real. They establish, without serious controversy, that the site was actively engaged in trade and commercial movement, during the period when Cleopatra ruled Egypt. That much is solid ground. The question is how far that solid ground extends before it becomes inference, and then speculation, and then something else entirely. Kathleen Martinez has spent close to 2 decades at Taposiris Magna, in part because she believes, and has argued publicly, that Cleopatra's tomb may be somewhere within or near the temple complex. The tomb of Cleopatra and Mark Antony has never been definitively located, and its absence from the archaeological record is one of the great unresolved questions in the study of the ancient world. That absence is itself a kind of invitation. For Martinez, the tunnel, the coins, the submerged port structures, and the temple's known association with the cult of Osiris and Isis, a cult that Cleopatra deliberately identified herself with, combine into a hypothesis that the site was not merely a regional religious and commercial centre, but a place of deliberate elite concealment. In her framing, a passage of this scale and this apparent complexity connecting a major temple to a submerged port is exactly the kind of infrastructure you would build if you wanted to move burial goods, ritual objects, or the remains of royalty without public spectacle or the risk of interference. That is a coherent hypothesis. It is also, as scholars like Roland N. March and Claire Gilmore have carefully noted, a hypothesis without direct archaeological support. The engineering of the tunnel matches an aqueduct tradition with documented parallels going back to the Eupalinos tunnel of the 6th century BC. The presence of Ptolemaic coins on a seafloor near a Ptolemaic-era temple and harbour is archaeologically expected, not archaeologically remarkable. Coins bearing a ruler's portrait are among the most commonly distributed objects of any ancient Mediterranean economy. Their presence tells us the site was occupied and commercially active during Cleopatra's reign. It does not tell us that the tunnel was used to transport her burial goods, or that her tomb lies somewhere beneath the sand. This is the mechanism by which myths form around incomplete finds. It is not usually dishonesty, and it is rarely pure invention. It is the very human tendency to fill the space between what is known and what is possible with the most dramatically compelling option available. The incomplete archaeological record at Taposiris Magna creates genuine interpretive space. Cleopatra's missing tomb is one of the most romantically charged unsolved problems in the history of archaeology. Put them together in the same geographic location, add the physical reality of a long underwater passage whose function remains debated, and the narrative almost assembles itself. The same pattern appears throughout the history of underground and underwater discovery. Secret tunnels gather round famous figures the way shipwrecks gather round legends of treasure fleets. Not because the association is always false, sometimes it's entirely accurate, but because the dramatic possibility pulls attention, funding, and storytelling toward it in ways that can quietly reshape how evidence is presented and evaluated. When preliminary findings are announced under headlines about Cleopatra, the interpretive framework is partially set before the evidence is fully examined. None of this means the Martinez hypothesis is wrong. The possibility that Taposiris Magna served elite or ritual transport functions alongside or instead of hydraulic ones is a legitimate subject of scholarly investigation, and the work being done there is producing real finds that advance our understanding of Ptolemaic maritime infrastructure regardless of where the tomb question ultimately lands. What it does mean is that the version of the story circulating in popular media, where the tunnel is presented as Cleopatra's secret passage, effectively confirmed, has moved well past what the current evidence supports. There are genuine strategic and logistical reasons why ancient rulers and their engineers would have built concealed or restricted access maritime passages. The Roman Grotta di Coceu, constructed around 36 BC, demonstrates this logic clearly. It created a hidden channel connecting a coastal lake to the sea, allowing military ships to move between the two without being visible to enemies or exposed to open water storms. That was not speculation. It was documented Roman military engineering solving a specific tactical problem. If the Romans were building concealed lake-sea channels for fleet movements in the same century Cleopatra was ruling Egypt, the general idea of secure maritime access for high-value purposes is historically plausible. Infrastructure designed to protect cargo, whether that cargo was grain, treasury goods, weapons, or objects of ritual significance, from piracy, political rivals, or simple public observation, was not an exotic fantasy. It was a recognized tool of ancient statecraft. But plausibility in general is not the same as evidence in particular. The existence of the Grotta di Coceo tells us that ancient Mediterranean powers did build this kind of infrastructure when they needed it. It does not tell us that the Taposiris Magna tunnel was built for the same purpose. That determination requires evidence from the site itself. The completed inscriptions analysis, the full stratigraphic record of the tunnel's interior, the detailed publication of what divers actually found at the seaward terminus. Until that evidence is in, the strategic motive for a secret passage remains exactly what it is, a possible explanation, not a demonstrated one. What Taposiris Magna has revealed in the meantime is something valuable in its own right that does not require the Cleopatra association to be significant. A 1,305-metre underground passage of Greco-Roman construction, partially submerged, connecting a major religious site to a seaport, is an extraordinary piece of ancient engineering by any measure. The artefacts recovered from the surrounding waters show sustained, organised maritime activity across several centuries. The structure invites serious questions about how ancient Mediterranean societies managed the movement of goods and people between land and sea, and about how much of that movement we have simply failed to see because it happened underground and underwater. The lure of secrecy is real, and it is not entirely misplaced. These structures do represent a kind of concealment, even if the concealment was functional rather than conspiratorial. Tunnels that moved water or goods below ground, away from weather and observation, designed by engineers who understood the value of protected transit. The question is whether we can keep that genuine mystery clearly separate from the layer of accumulated legend that attaches itself to any site unfortunate enough to be near something that Cleopatra once touched. The archaeology deserves that separation, and so does Cleopatra. Egypt is not the only place where this investigation leads. If the story of Taposiris Magna raises questions about how ancient Mediterranean societies engineered concealed or protected maritime access, then Caesarea Maritima, on the coast of what is now Israel, offers a very different kind of evidence from a very different kind of builder, and it broadens the picture considerably. Herod the Great was not a man who did things quietly. When he decided to build a harbour on an exposed stretch of the Levantine coastline, around 22 BCE, he did not select a naturally sheltered bay or an existing port with established infrastructure. He built one from almost nothing, using Roman hydraulic concrete poured into the open sea, constructing 2 massive breakwaters on a coast that offered him almost nothing to work with. The harbour, which he named Sebastos, the Greek equivalent of Augustus, a clear statement of political allegiance, was inaugurated around 10 BCE and was, by the standards of its time, one of the most ambitious pieces of maritime engineering anywhere in the Roman world. A southwestern sea wall running approximately 650 metres into open water, a northern breakwater of around 250 metres. Between them, an entrance channel wide and deep enough to admit ancient merchant vessels of considerable size, built not from the patient accumulation of centuries of harbour improvement, but from a single sustained engineering campaign, executed in a generation. What Herod built did not survive above the waterline. The harbour silted, the superstructures fell, the city declined, and over 2 millennia the sea reclaimed most of what the builders had razed. But it did not destroy it. The breakwaters and the architectural complex they supported are still there, lying at depths of 6 to 9 meters across the middle and outer basins, submerged but not gone. And here is what makes Caesarea Maritima relevant to this investigation, rather than merely to the history of Roman engineering. The geometry of the original entrance system is still legible down there, if you have the tools to read it. In 2025, a research team conducted a high-resolution multimodal remote sensing campaign across the submerged harbour that produced results significant enough to reframe how scholars understand the site. The survey combined diver-borne photogrammetry, essentially underwater 3D scanning using carefully calibrated photography, with multi-beam sonar, sub-bottom profiling, and frequency domain electromagnetic sensing. The result was a set of detailed three-dimensional models of the harbour entrance, the breakwater alignments, and the distribution of large stone blocks, some of them measuring up to 3 meters across, that once formed the northern sea wall, sitting at an average depth of around 7.6 meters, with an estimated surviving masonry volume of approximately 221 cubic meters. On the northern breakwater alone, these are not ambiguous traces. They are the recoverable skeleton of a monumental engineered structure, and the 2025 survey made it possible to read that skeleton with a clarity that previous methods simply could not achieve. What the survey revealed about the harbour entrance specifically is where the conversation about concealed or controlled access becomes relevant. The 2025 data documented the preserved geometry of the engineered inlet in enough detail to understand how the channel was designed to funnel and control the movement of ships, but it also identified something flanking that entrance that had not been previously mapped with this level of precision. 2 monumental stone columns, approximately 6 meters by 6 meters at their base, standing roughly 6 meters above the seabed at a depth of around 8.6 meters. Ancient literary sources, Josephus among them, describe statues positioned at the entrance to Sebastos to greet incoming vessels. These columns are almost certainly the foundations or remnants of those structures. They functioned as a formal ceremonial gateway, marking the threshold between open sea and controlled harbour space. Now, this is where the investigation requires the same care it demanded at Taposiris Magna. Scholars debate whether any of the submerged elements at Caesarea Maritima constitute tunnels in any meaningful sense, or whether they represent collapsed breakwater sections, silted channels, or the natural accumulation of architectural debris from a structure that fell apart over centuries. That debate is legitimate, and it has not been resolved. The 2025 survey does not settle the question of whether there were hidden or restricted access passages built into the harbour system. It does not claim to. What it does is establish with unprecedented precision the geometry of an entrance system that was clearly designed to regulate access, to channel movement, and to present arriving ships with a specific controlled experience of entry. Whether that controlled experience extended to passages or conduits not visible from open water is a question the data raises without fully answering. The reason this matters beyond Caesarea itself is that Herod's harbour was not an anomaly. It was an extremely well-documented example of a wider Roman and Hellenistic tradition of sophisticated harbour engineering, and it was operating at exactly the same historical moment, the late 1st century BCE, when the Taposiris Magna tunnel was in use, and when the broader Mediterranean world was developing the kind of complex port infrastructure that might reasonably have included protected or concealed access points. If Herod's engineers were capable of pouring hydraulic concrete into the open sea to build breakwaters hundreds of meters long, the question of whether comparable ingenuity was applied to underground or restricted access passageways at other sites of comparable ambition is not an unreasonable one to ask. Caesarea Maritima also demonstrates something important about the relationship between visibility and design, intent in ancient harbour engineering. The monumental columns at the entrance were not hidden. They were meant to be seen to announce the harbour's grandeur and its ruler's power. But the 2025 survey shows that immediately behind that display of architectural presence, the actual mechanics of the entrance channel were carefully engineered for function rather than spectacle. The controlled geometry of the inlet, the positioning of the breakwaters to manage wave energy and ship traffic, the depth calibrated for specific vessel drafts. These were practical decisions, and they were decisions made by engineers who understood that the most important aspects of a harbour's function were not always the ones most visible to an arriving sailor. That tension between display and concealment, between the ceremonial gateway and the engineered channel behind it, is not unique to Caesarea. It appears across ancient Mediterranean harbour infrastructure, and it is one of the reasons this investigation keeps producing more questions than it resolves. The structures are real. The engineering traditions behind them are documented. What remains genuinely uncertain is the full extent of what those traditions produced beneath the waterline, and whether Caesarea, like Taposiris Magna, represents a visible corner of something much larger that the sea has not yet finished giving back. So the question becomes unavoidable at this point. Were any of these passages actually secret? Not in the loose sense of being forgotten by time, not in the archaeological sense of simply being submerged and therefore invisible to later centuries, but deliberately concealed, intentionally restricted, designed so that someone arriving at Caesarea or Taposiris Magna by sea would not know they were there unless they were supposed to. It is a question worth sitting with carefully, because the answer is genuinely not settled, and the evidence at Caesarea in particular pushes back harder against the romantic version of the story than many accounts tend to acknowledge. Start with the geometry, because that is where the clearest data lives. The 2025 high-resolution survey of Caesarea Maritima's submerged entrance channel documented a passage running between the northern and southern breakwaters at a depth of 6 to 9 metres, wide enough and deep enough to admit large ancient merchant vessels without difficulty. That is not a secret conduit. That is a main commercial thoroughfare. The scale of it is unambiguous. A purpose-built concealed passage would be narrow, deliberately obstructed, designed to limit visibility and restrict access to those who knew exactly where to look and how to navigate it. What the 2025 data shows instead is a generously proportioned engineered inlet optimized for volume traffic, the kind of opening a busy Roman port needed to function as an economic engine, not the kind of aperture you would design if your primary goal was to move people or cargo without anyone noticing. The northern breakwater tells a similar story. It is built from massive ashlar blocks, some of them reaching 3 meters in length, in a construction style consistent with Herodian engineering practice. These are prominent, monumental, expensive pieces of infrastructure that announce their own presence. The southern breakwater is different. It shows evidence of later rubble fill and scattered stone accumulation. But the current scholarly interpretation of those gaps and irregularities is not that they represent covert access points. They are more plausibly read as a repair phase, the visible signature of later modification and partial collapse, not purpose-built concealed gates. That distinction matters because it is very easy to look at an irregular scatter of underwater masonry and impose a narrative of hidden design onto what is more probably just entropy. And yet the question of restricted access is not the same as the question of secret access, and that distinction deserves its own careful treatment. Caesarea's massive sea walls, some of them incorporating blocks estimated at 50 tons or more, were described by ancient observers as a fortress at sea. That phrase is not primarily about concealment. It is about exclusion. The harbour was fortified against winter storms and hostile ships, both at once, and those two threats required broadly similar engineering responses: heavy, permanent, storm-resistant barriers that could also function as defensive perimeters. A harbour designed to keep bad weather out is, by the same geometry, a harbour that can control who enters and who does not. Security and secrecy are different things, but they share infrastructure, and that shared infrastructure is part of what makes the archaeological picture at Caesarea genuinely ambiguous. Military logistics add another layer of complexity. Archaeology at Caesarea has recovered evidence of high-value cargo movement through the port, leading it's dated to the period between 83 and 96 CE, for instance, suggesting that the harbour handled goods valuable enough to justify restricted handling and controlled access. You do not need a secret tunnel to move valuable cargo securely. You need guards, scheduling, and physical barriers that can be opened and closed on demand. But if those barriers existed in the ancient harbour, and if some of them were built into the submerged architecture rather than sitting on the surface, where centuries of silting and collapse could simply erase them, the 2025 survey's 3D models might be preserving their outlines without yet being able to confirm their function. The data identifies gaps in the breakwater alignment. It cannot yet tell us whether those gaps were always structural voids, whether they were passages that could be blocked, or whether they are simply the accumulated damage of 2,000 years. This is what secrecy would actually look like archaeologically in a working Roman port, and it is useful to think through that carefully. A deliberately concealed navigation route would almost certainly leave specific physical signatures, narrow shafts rather than broad channels, evidence of deliberate obstruction that could be cleared and replaced, possibly the remains of lockable or removable stone elements. The 2025 survey does not find those signatures at the Caesarea entrance. What it finds is collapsed debris, repair zones, and the structural remains of a harbour that was built large, used heavily, and eventually overwhelmed by the same forces of time and sea that have buried most of the ancient Mediterranean's infrastructure. The ancient literary record does not resolve this cleanly either. Josephus, Strabo, and Pliny each refer in their own ways to underground vaults and subterranean elements associated with Caesarea and comparable harbours. Josephus specifically describes continuous edifices and underground passages linking the city and the port, but when you read those passages in context, the structures he is describing sound like storage vaults and drainage systems, the practical underground infrastructure of a large commercial harbour, designed to keep goods dry and water moving, not to conceal the movement of ships or sailors. No surviving text makes an unambiguous claim for a deliberately hidden navigation route at Caesarea, and no archaeological feature currently identified at the site demands that interpretation. What this leaves us with is something more nuanced than either the straightforward confirmation or the straightforward dismissal of the secret passage idea. The harbour at Caesarea was designed to regulate access, to control who passed through its entrance and under what conditions. It was fortified, it handled sensitive cargo, and it had underground infrastructure whose full extent is still being mapped. Some of its submerged elements are still not fully explained. The distinction between a restricted access military logistics channel and a secret passage is real, but it is not always visible in the archaeological record, particularly when the record is incomplete, which at Caesarea it still is. The dating of the southern breakwaters renovation remains debated. Whether any of its blocks were ever designed to be removable is an open question. The 2025 survey is the most detailed look anyone has taken at this site, and it explicitly stops short of claiming to have answered the function question for every anomalous feature it documented. So the honest answer, held at the level the evidence actually supports, is this. The submerged structures at Caesarea Maritima are almost certainly not secret tunnels in the dramatic sense. They are the remains of a sophisticated, heavily engineered harbour system that combined commercial function with military fortification, that moved valuable cargo and controlled access, and that has left an incomplete record on the seabed. Whether that record conceals something more than a very well-built Roman port, whether somewhere in the gaps and the debris there is evidence of deliberate concealment that the current data cannot yet confirm or rule out, is a question the archaeology is still in the process of answering, and that process is moving faster now than it ever has before. The archaeology moves fast, but it does not move alone. Running alongside every dive survey and every sonar pass is another kind of evidence, older and less precise but impossible to set aside. The testimony of ancient writers who were actually there, or who spoke to people who were, or who compiled what earlier observers had recorded before the sea took everything back. 3 names come up again and again in any serious discussion of hidden harbour infrastructure in the ancient Mediterranean: Strabo, Pliny the Elder, and Josephus. Each of them wrote within a few generations of the major construction phases at Caesarea and Alexandria. Each of them described maritime infrastructure with a specificity that, read carefully, hints at features that were not meant to be universally visible. And each of them, read even more carefully, stops well short of confirming the existence of a coordinated network of secret underwater passages. That gap between what the texts suggest and what they actually state is where historians have to do the most careful work, and where it is easiest to go wrong in either direction. Start with Strabo, writing his geography in the late 1st century BC and early 1st century AD. In Book 17, he describes the coastline west of Alexandria with considerable detail, and within that description he refers to a harbour that was, in his phrasing, dug by the hand of man and hidden from view, a maritime space that functioned, it seems, as a private harbour for the royal household, concealed from ordinary sight and accessible only to those who were supposed to use it. That is a striking phrase. A harbour hidden from view on a coastline. Strabo walked, or at least surveyed carefully, near the same stretch of coast where the Taposiris Magna tunnel aqueduct was eventually discovered, running 1,305 metres from Lake Maritima toward the Mediterranean Sea. The proximity is suggestive. The connection is not confirmed. The phrase itself carries an interpretive ambiguity that historians cannot wish away. Hidden from view might mean a harbour cut into a cliff face, invisible from the open sea until you were already at its entrance. It might mean a harbour screened by natural features, a headland, a sandbar, a stand of shoreline growth that has long since disappeared. It might mean something considerably more engineered than either of these options. The text does not say. What it gives us is a literary trace of a maritime space that was designed to be private, possibly concealed, associated with royal or elite control of access. Whether that maps onto any of the submerged structures archaeologists have been mapping in recent years is a question the archaeology itself has to answer, because Strabo cannot answer it for us. Pliny the Elder, writing his natural history in the 70s AD, describes the harbour at Caesarea in terms that are almost specifically designed to emphasize scale. He calls the breakwater stupendous, a word he does not use lightly, and details the extent of the engineered works in a way that makes clear he understood these were extraordinary structures even by Roman standards. But Pliny does not describe tunnels. He does not describe hidden passages. What he emphasizes is visibility, monumental permanence, the sheer ambition of building something this large in open sea. His account points toward the same harbour complex whose submerged remains the 2025 survey mapped in high-resolution 3D, the massive ashlar breakwaters, the broad entrance channel, the engineering tradition that poured concrete piers into the Mediterranean until they had created a fully functional port from nothing. Pliny's Caesarea is grand and exposed, not hidden. His testimony is valuable precisely because it represents one end of the interpretive range. a witness who saw the harbour's public face and described it as such. Josephus is where the language gets more interesting and requires more caution. Writing in the late 1st century AD, he refers in The Wars of the Jews to the inner retirements of the water at Caesarea, a phrase that has attracted considerable scholarly attention because it implies enclosed, recessed spaces within the harbour complex that were not simply open to the sea. He goes further in Jewish antiquities, describing a secret underground passage running from the Antonia fortress toward the inner temple, a vaulted conduit linking two major structures through a route that was not meant to be common knowledge. The geographical reference there is to Jerusalem, not Caesarea specifically, but the passage demonstrates clearly that Josephus was aware of and willing to describe deliberate underground infrastructure designed to move people or things without those movements being observed. The question historians ask when they encounter this material is precise and practical. What kind of structure is Josephus actually describing, and does anything currently identifiable in the archaeological record correspond to it? The honest answer at both Caesarea and the Alexandria coastline is that the match remains unconfirmed. What archaeology has found at Caesarea is a sophisticated harbour with vaulted storage elements, drainage infrastructure, and submerged breakwaters whose full function is still being established. What it has not found is a structure that corresponds unambiguously to a deliberately concealed navigation route of the kind Josephus's language might seem to imply. His inner retirements of the water most plausibly describe the practical underground infrastructure of a large commercial port, the storage vaults, the water management systems, the below-deck architecture that kept a harbour like Caesarea functioning as an economic machine. That interpretation is not nearly as dramatic as a secret passage, but it is better supported by the evidence currently available. The relationship between these texts and the physical sites is precisely what makes Mediterranean underwater archaeology so methodologically interesting right now. Literary sources like these are not ignored. They are treated as targeting documents, guides that tell field researchers where to look and what anomalies in the data might be worth investigating more closely. When a Strabo reference describes a hidden harbour near Alexandria's coast, and a team of archaeologists subsequently finds a 1.3-kilometre tunnel aqueduct running under the seabed in that general region, the text and the structure enter into a conversation that neither can conclude alone. The tunnel at Taposiris Magna is real, documented, physically mapped. Whether it is the structure Strabo was gesturing toward is a question that cannot be answered by reading the text more closely, because the text was never precise enough to support that identification. This is where the discipline of history does its most demanding work, holding open a space between the suggestive and the confirmed, refusing to collapse the gap in either direction. The ancient writers clearly knew that large-scale hidden infrastructure existed in the Mediterranean world. They described it with varying degrees of specificity. They left enough detail to make a reader 2,000 years later genuinely curious about what might still be waiting on the seabed. But they did not provide a map, and they did not confirm a network. What they provided was a set of literary coordinates that the archaeology is only now beginning to evaluate with the precision those hints deserve. Multi-beam sonar, photogrammetric modelling, sub-bottom profiling running over the same coastlines that Strabo walked, and Pliny described, and Josephus included in histories that were written to be believed. The writers pointed. The divers are still looking. The divers are still looking. And they are looking with tools that would have been unimaginable to every scholar who spent the preceding century reading Strabo and Pliny, and concluding that whatever the ancient writers hinted at was probably gone forever beneath sediment and salt water. The transformation in what underwater archaeology can actually see and measure has happened fast, concentrated largely within the last 2 decades, and it has fundamentally changed the terms of the investigation. Structures that were previously invisible, buried under 2 meters of silt, blurred into ambient noise by low visibility coastal water, or simply too fragile to approach without destroying them, are now documentable in 3 dimensions with centimetre-level accuracy. That shift explains in large part why the conversation about concealed Mediterranean maritime infrastructure has become so much more urgent and specific in recent years. It is not only that archaeologists are asking better questions, it is that they now have instruments capable of receiving answers. The most directly transformative of these tools, particularly for the kind of detailed structural documentation that ancient harbour sites demand, is diver-borne photogrammetry. The technique is conceptually straightforward. A diver moves through a submerged site carrying a calibrated camera rig, capturing overlapping frames, typically around 3 per second, with reference targets distributed across the structure to lock the geometry. That footage is then fed into processing software, and the result is a dense point cloud, a 3-dimensional digital record of every surface the camera has seen, accurate to within a few centimetres, navigable on a screen and measurable without anyone going back into the water. For fragile masonry, stone blocks that have sat on a seabed for 2,000 years and cannot bear contact, this is not just convenient. It is the only way to take a measurement at all. You document without touching, and the model you produce can be examined indefinitely without any further risk to the structure itself. The limitations matter, and researchers are careful about them. Photogrammetry performance degrades sharply in turbid water or poor light conditions. Many Mediterranean coastal sites, especially those adjacent to active harbours or river mouths, sit in exactly those conditions, silty, churned by boat traffic, seasonally murky in ways that make close-range camera work unreliable. The technique works beautifully in the clear, calm conditions you find in a textbook. Field conditions are frequently not textbook conditions, and no serious researcher treats photogrammetric output as a substitute for thinking carefully about what the camera did and did not capture on a given dive. Where photogrammetry fills in the fine-grained surface detail, multi-beam echo sounders, MBES, cover the surrounding terrain. These instruments, mounted to a survey vessel, emit acoustic pulses across a wide swathe of seafloor and receive the returns to build a precise bathymetric grid, a high-resolution map of the seabed's topography, across potentially large areas in a single survey pass. The bathymetric data tells you where the bottom rises and falls, where features interrupt the smooth profile of undisturbed sediment, where something that might be a wall or a threshold or a channel edge is waiting to be investigated more closely. What it does not tell you is what is buried underneath. A structure hidden beneath 2 meters of sand is acoustically invisible to MBES, which records only surface morphology. Impressive as the technology is, it reads the skin of the seabed, not its interior. Sub-bottom profilers address that gap. They emit low-frequency acoustic pulses at frequencies MBES cannot use, that penetrate the seabed rather than reflecting from it, and they receive returns from interfaces buried within the sediment. Buried walls, collapsed ceilings, the outlines of structures that have not seen light in centuries. Penetration depth depends heavily on sediment type. In muddy conditions, field tests have demonstrated clear stratigraphic imaging to depths of 10 meters or more, with resolution fine enough to distinguish the profile of individual amphorae within a wreck mound. In coarser sediment, sand, gravel or rock, penetration is much shallower and resolution suffers accordingly. The technology is powerful and increasingly standard in maritime survey work, but it is not a ground-penetrating radar in the sense of giving you a clear image of what is below. It gives you acoustic reflections that trained specialists must interpret, and that interpretation carries uncertainty that responsible researchers carry with them through every subsequent step. Remotely operated vehicles, ROVs, complete the standard toolkit. They provide video and sensor data at depth, making it possible to examine areas that are too dangerous or too inaccessible for divers. In deep-water contexts, where human dive operations are physically impossible, ROVs are not supplementary tools but the entire investigation. In the shallow, high-energy environments of ancient Mediterranean harbours, their role is more complicated. Tethered operation in confined harbour architecture is expensive and physically awkward, and the cameras ROVs carry, however capable, typically lack the resolution and close-range manoeuvrability of a diver with a dedicated lighting rig working at arm's length from the stonework. They remain valuable, particularly for initial reconnaissance or for reaching features that divers cannot safely approach, but they are not a universal substitute for human divers in shallow coastal contexts. What the 2025 Caesarea Maritima project demonstrated, and why it has become something of a reference point in discussions of what modern methodology can actually produce, is the value of combining all of these tools within a single integrated survey. Diver photogrammetry produced a detailed 3D model of the harbour entrance and its immediate architecture. MBES supplied the surrounding bathymetry, placing that entrance in its full topographic context. Sub-bottom profiling identified subsurface features that neither surface scanning nor diver observation could have reached. Together they revealed an entrance channel running 6 to 9 meters deep, significantly greater than the roughly 2 meters previously assumed, and confirmed the presence of massive ashlar blocks up to 3 meters in length within the northern breakwater. Neither of those findings was accessible to scholars working with the methods available even 20 years ago. Both of them have direct implications for interpretations of how the harbour was used, and critically, what kinds of access it was designed to permit or restrict. That is the connection that runs directly back to the question this investigation keeps circling. The recent surge in serious scholarly and public discussion about concealed maritime infrastructure in the ancient Mediterranean is not driven primarily by new historical texts or revised readings of Strabo. It is driven by the fact that tools have appeared which lower the detection threshold for hidden structures, far below what earlier generations of researchers could reach. Every decade that passes sees the instruments become more capable, the processing software more sophisticated, the integrated survey methodology is more precise. Sites that were surveyed 30 years ago and declared understood are being revisited with multi-beam, sub-bottom profiling and photogrammetric rigs, and they are revealing things the earlier surveys missed entirely. The Mediterranean seabed has not changed. Our ability to read it has, and it is still changing fast. Reading a point cloud, though, is not the same as understanding a harbour. The raw output of a photogrammetric survey or a multi-beam run is dense, precise, and in a very real sense overwhelming. Millions of data points describing a geometry that has been fragmented by 2,000 years of sea level change, biological growth, sediment drift, and structural collapse. Turning that data into an interpretation requires another step. Building something you can actually reason about. That is where three-dimensional modelling and increasingly augmented and virtual reality enter the picture, and the story of what those tools can and cannot do for ancient Mediterranean sites is considerably more complicated than the promotional language around them sometimes suggests. The 2025 Caesarea Maritima project offers the clearest recent example of what rigorous 3D modelling actually produces in practice. Researchers working on the harbour entrance and northern breakwater did not simply render a photogenic reconstruction and call it archaeology. They used the dense photogrammetric meshes and multi-beam data together with GIS and CAD workflows to quantify what they were looking at. Individual stone blocks were measured for surface area, some running between roughly 92 and 97 square meters of exposed face, and volumes were calculated for discrete collapse zones, ranging from approximately 95 to 222 cubic meters, depending on the feature. Those numbers matter because they let you ask a structural question in structural terms. A volume in that range, distributed across a specific spatial footprint, behaves differently from a pure wall section, a sealed tunnel ceiling, and a post-collapse debris field. The 3D model does not answer the question for you, but it constrains the space of plausible answers in ways that visual inspection alone, however experienced the eye, simply cannot. That same quantitative framework allows researchers to test functional hypotheses in something approaching a controlled way. If a feature at Caesarea appears to be a channel or passage based on its morphology, you can use the integrated 3D data to simulate water flow through the proposed geometry, check whether the dimensions are consistent with vessel clearance at the documented depths, and assess the structural stability of the surrounding masonry under load conditions plausible for an active working harbour. None of that analysis replaces physical excavation or removes genuine ambiguity about original intent. What it does is filter out interpretations that are structurally or hydraulically implausible before anyone commits resources to testing them in the field. That is not a small thing. Underwater excavations are expensive, logistically complex, and potentially destructive to the very features you're trying to understand. The honest caveat here is worth stating plainly. Volume and surface calculations in underwater contexts rely on assumptions about where the seabed baseline sits, and they cannot account for subsurface voids or buried structural elements that the survey instruments did not image. A feature that models cleanly as a collapsed wall section might contain a hidden passage beneath it. A zone that looks like a debris field might be protecting intact architecture underneath. The model captures what the sensors captured, and responsible researchers are explicit about the fact that even a high-resolution 3D reconstruction is a partial record of a site that extends beneath the visible surface in ways the current data does not resolve. What ontology-based data management adds to this picture is something less visually dramatic, but arguably more important for the long-term project of understanding these sites. The challenge with complex underwater excavations is that they generate multiple types of evidence simultaneously. Geometric models, stratigraphic records, inscription analyses, artifact catalogues, dating results, and interpretive notes. And those data streams are produced by different specialists using different tools, and often stored in incompatible formats. An ontology is a formal data structure that defines the relationships between all of those categories in a way that a computer can navigate. In the Xlendi shipwreck project, researchers demonstrated this approach directly. Photogrammetric outputs were modelled using an ontological framework and linked to virtual and augmented reality visualizations, creating what they described as a bidirectional connection between the graphical representation and the underlying archaeological information. You could look at a reconstructed hull plank in VR and immediately access the stratigraphy record associated with that deposit, the dating evidence, and the interpretive notes, all through the same interface without leaving the visualized environment. For a site like Taposiris Magna, where the 1,305-metre tunnel aqueduct runs partly on the seabed and partly underground, where inscriptions are still under analysis, and where the debate between an aqueduct function and a harbour access function remains genuinely unresolved, this kind of integrated data management is not a luxury. The moment new inscription analysis produces a dating result, or a revised interpretation, that information needs to flow immediately into the same framework that is holding the geometric model and the spatial analysis. If those systems are separate, researchers working on different aspects of the same site can develop incompatible interpretations without realizing it, and the literature accumulates contradictions that are purely administrative rather than genuine scholarly disagreements. Ontology frameworks address that problem, though it is worth acknowledging that those frameworks are still evolving, that vocabulary choices differ across projects, and that the interoperability advantage depends entirely on whether the wider research community adopts compatible standards. That adoption is uneven at present. Augmented and virtual reality add the dimension of access, in both a scholarly and a public sense. Scholars working on harbour reconstructions can step inside a proposed interpretation of the Caesarea entrance channel at documented scale. Look at how the breakwater geometry relates to the channel depth. Walk the hypothetical line a vessel would have taken on approach, and sense spatial relationships that a screen display of a 3D mesh simply does not convey. Alternative reconstructions can be overlaid and compared in the same VR space. Here is the interpretation where this feature is a sealed passage. Here is the interpretation where it is a collapse zone. Here are the structural implications of each, allowing a kind of hypothesis testing that previously required either physical models or an unusual capacity for spatial reasoning from two-dimensional site plans. For the public and for students, the same technology offers something closer to the actual experience of being there. Not a flat photograph of a murky seabed, but a navigable space where the relationship between a 2,000-year-old harbour wall and the sea it was built to manage becomes immediate and legible. The honesty that has to accompany all of this is that better visualization does not resolve genuine uncertainty. A harbour that was ambiguous before the 3D model is still ambiguous after it, more precisely ambiguous, constrained within a smaller set of plausible interpretations, but not definitively solved by the rendering. The reconstruction is always an argument, not a discovery. The argument can be better or worse supported, more or less consistent with the physical evidence, more or less explicit about where the assumptions are. The best current work in Mediterranean underwater archaeology is careful about exactly that distinction. What these tools promise, beyond any individual site, is coverage. There are dozens of ancient harbour complexes along the Mediterranean coast that have never been subjected to integrated multi-beam, photogrammetric and sub-bottom surveys. Many of them sit in regions where modern development pressure, climate-driven sea level change and increasing marine traffic are actively degrading the sites. The question of whether the Taposiris Magna tunnel represents an isolated curiosity or part of a wider pattern of concealed maritime infrastructure cannot be answered from the handful of sites currently well documented. What 3D modelling, AR and VR, and ontology-based data management collectively offer is the possibility of documenting those sites fast enough and in enough detail to hold that question open until the evidence base is large enough to support a real answer. So the question that the evidence keeps circling back to is not just what these structures were, but why anyone would go to the trouble of building them in the way they were built. Why conceal a passage, fortify a harbour entrance beyond what basic shelter requires, or route a tunnel beneath the seafloor when a surface canal might have served the same basic function? The motives that scholars have proposed fall into several overlapping categories, and it is worth being honest from the start that none of them has been definitively proven for any single site. What we have instead are hypotheses of varying strength, each supported to a greater or lesser degree by the physical evidence and the historical context. The most straightforward motive is economic, and it is also the one with the most direct material support at both Taposiris Magna and Caesarea. Controlled cargo movement was a central preoccupation of ancient states. Tax collection, customs enforcement, and the prevention of smuggling all depended on regulating where goods entered and left a harbour. At Caesarea, leading gates dated to between 83 and 96 CE, were recovered from the northern breakwater, high-value metal moving through a port that had the physical infrastructure to monitor and record what passed through it. The entrance channel ran at depths of 6 to 9 metres, wide enough for large merchant vessels, which means that access to the inner basin was a specific regulated event. A ship could not simply drift in through a gap in the shoreline. It had to approach through an engineered passage where its cargo could theoretically be inspected and taxed. Whether that constitutes a secret infrastructure or simply good harbour engineering is part of the legitimate debate, but the economic logic of controlled access is not in doubt. At Taposiris Magna, the economic motive has a different texture. The tunnel runs 1,305 metres from Lake Maritima to the Mediterranean, cut 15 metres below ground, and the artefacts recovered from its submerged sections include amphorae, pottery, and coins bearing Cleopatra's portrait. These are not the residue of a purely utilitarian water supply. They suggest active movement of goods, possibly trade goods, possibly materials of particular value or sensitivity, through a passage that was, by its very nature, invisible from the surface. A cargo moved underground does not appear in harbour records. It does not pass a customs post. Whether that invisibility was the point, or simply a consequence of a structure built primarily for water management, is something the current evidence cannot fully resolve. Military motives are equally plausible and in some respects more straightforward to argue. Moving supplies undercover, controlling who can approach a harbour entrance, and providing a secure berth for naval units all have obvious strategic value in a Mediterranean world where piracy was endemic and naval conflict was a recurring reality. Caesarea was built under Roman imperial authority and inaugurated in 10 BCE as a statement of Roman presence on the Levantine coast. The massive breakwaters, roughly 250 metres on the northern arm and 650 metres on the southern, were periodically reinforced to keep the port operational, which suggests sustained military and administrative investment beyond what pure commercial logic would necessarily demand. A harbour that could shelter a fleet through winter storms and provide a defensible entrance was worth maintaining even through the considerable effort of underwater repair in ancient conditions. The fortified geometry of the entrance is consistent with a design that considered access control as a primary rather than incidental requirement. Environmental motives add another layer that is sometimes underweighted in the discussion of concealment and secrecy. The Mediterranean is not a calm sea. Winter storms along the Egyptian and Levantine coasts are severe enough to sink ships and destroy unprotected harbour works, as the evidence of storm damage at Caesarea itself demonstrates. Building infrastructure that placed cargo transfer below the waterline or inside protected passages would have had the immediate practical benefit of making operations viable in conditions that would have shut down an open-shore harbour entirely. The Taposiris Magna tunnel's depth underground and its routing from an inland lake to the sea could reflect a straightforward desire to protect a water supply from contamination and disruption, an aqueduct function that served the practical needs of a community or a cult site without any strategic concealment intended at all. The fact that such infrastructure could also serve concealment purposes does not mean that concealment was the primary design goal. Then there are the ritual and elite motives, which are the hardest to assess from physical evidence alone, but which the specific character of Taposiris Magna makes difficult to dismiss. The site is a temple complex dedicated to Osiris, and Kathleen Martinez's ongoing excavation has proposed it as a candidate for Cleopatra's burial location. Coins bearing Cleopatra's portrait recovered from the tunnel are genuinely suggestive. Sacred sites in the ancient world routinely had passages and chambers that were accessible only to priests or to specific categories of worshippers, and the physical separation of sacred materials from ordinary traffic had both ritual meaning and practical security value. If the tunnel was used to move offerings, funerary goods, or politically sensitive materials associated with the Ptolemaic court, the decision to do so underground and away from the harbour's public face would have had multiple simultaneous justifications, religious, political, and logistical all at once. Mapping these motives onto the two sites as the evidence currently stands, Caesarea fits most comfortably with the economic and military hypotheses. The scale of the breakwaters, the depth and width of the entrance channel, the presence of high-value cargo, and the Roman state's demonstrated investment in maintaining the harbour over centuries all point toward infrastructure designed primarily for regulated commercial and naval use, with storm protection as a critical engineering constraint. The concealment interpretation, to the extent it applies at all, is probably better described as controlled access rather than secrecy in any clandestine sense. Taposiris Magna is genuinely harder to read. The tunnel scale, its routing, and the artifacts associated with it are consistent with multiple hypotheses simultaneously, and the scholars actively working on the site are careful not to collapse that ambiguity before the inscription analysis and further excavation have had a chance to constrain it. What the site does illustrate, more clearly than any other currently under investigation in the Mediterranean, is that the ancient world's builders were capable of conceiving infrastructure that served economic, military, environmental, and ritual purposes through a single physical form, and that our instinct to assign a single primary motive may reflect our own analytical categories more than the complexity of ancient intention. What the individual sites show in isolation is already striking, but the more important question, and the one that genuinely unsettles conventional accounts of ancient maritime infrastructure, is whether Taposiris Magna and Caesarea are exceptional achievements, or whether they represent visible peaks of a much broader tradition that is only now becoming legible to us. The case for a wider pattern rests on convergence across three separate cultural spheres, and it is worth laying out precisely what that convergence looks like before assessing how much weight it can bear. Start with the Greek world. The Eupalinos tunnel on Samos, completed in the 6th century BC, runs just over 1,000 metres through solid limestone, engineered from both ends simultaneously with a precision that still draws comparison to modern surveying practice. It was a functional aqueduct, but it was also a demonstration that a Mediterranean civilization had the organizational capacity, the mathematical tools, and the sustained will to move water, and everything that water implies about supply, survival, and control, through the earth rather than across it. That is the technical precedent. Move forward roughly 4 centuries and several hundred kilometres southwest to the Egyptian coast, where the tunnel aqueduct at Taposiris Magna was built at 1,305 metres, longer than the Eupalinos by nearly a third, and where the design so closely mirrors the Greek original that scholars have described it explicitly as a replica. The people who commissioned and engineered that tunnel knew the Eupalinos tradition. They were not independently arriving at the same solution. They were working within an established intellectual and technical lineage, extending it into a new geographic and cultural context. Then moved to the Roman Levant, where Caesarea Maritima's harbour Sebastos sits at depths of 6 to 9 metres with its breakwaters, entrance channel, and controlled access geometry intact enough to yield high-resolution three-dimensional models from multimodal surveys conducted as recently as 2025. The construction techniques, massive ashlar blocks, hydraulic concrete capable of curing underwater, breakwater geometries calculated to deflect specific wave patterns, appear in variations across the Roman Mediterranean wherever the state invested seriously in maritime infrastructure. And then there is Aegina in the Saronic Gulf, where a multidisciplinary study of the ancient harbour complex documented breakwaters, conical rubble structures, and passages that scholars have described using the Greek word kryptos, hidden or concealed. That word does not come only from the physical remains. It comes from Pausanias, writing in the 2nd century AD, who described the harbour at Aegina in precisely those terms. A passage described as hidden by an ancient writer, identified in the physical record by modern survey technology, at a site geographically and chronologically distinct from either Taposiris Magna or Caesarea. That is not coincidence easily dismissed. Strabo adds another thread. In his geography, he describes a harbour, dug by human hands and hidden from view, in terms that suggest the concealment was a deliberate and noted feature rather than an incidental one. Pliny and Josephus contribute their own passing references to guarded or concealed harbour passages in Egypt and the Levant. Taken individually, any one of these literary hints might be explained away. Taken together, across different authors, different periods and different regions, they form a framework that the physical evidence at multiple sites now appears to be filling in. This is the strongest version of the argument for a broader Mediterranean phenomenon. Geographically dispersed sites share design features, construction techniques, and the quality of concealed or controlled access. Ancient literary sources from multiple independent traditions describe hidden harbour passages as real and notable. And the same engineering vocabulary, long tunnels, hydraulic concrete, controlled channel widths, breakwater geometry, appears in Greek, Egyptian, and Roman contexts, as though these cultures were drawing from a shared repertoire rather than reinventing independently. Now, for the reasons to hold that argument at arm's length, because they are serious ones. The first is classification. The disagreement over what actually counts as a tunnel, as opposed to an aqueduct, a collapsed breakwater, a silted natural channel, or a harbour entrance that simply happens to be deep, is not a minor technical dispute. It goes to the heart of whether these sites are genuinely comparable. If the Taposiris Magna structure is primarily a water supply aqueduct that happens to pass through a coastal landscape, then its resemblance to Caesarea's entrance channel is considerably less meaningful than it first appears. Scholars are actively debating this, and the classification problem does not resolve itself by selecting the most dramatic interpretation. The second problem is dating. The Taposiris Magna tunnel's precise construction date is still under analysis, with inscription work ongoing. Without secure dates, the sequencing of the tradition, who influenced whom, which sites represent innovations and which represent copies, remains speculative. A pattern that looks coherent when sites are placed in rough chronological order may look very different once precise dating tightens the sequence, or reveals that structures assumed to be contemporary were actually separated by centuries. The third and most fundamental problem is that physical continuity between sites has not been demonstrated. What we have are a series of individual discoveries, each with its own local context, each with its own contested interpretation, linked by shared engineering features and a handful of textual hints. That could mean a coordinated Mediterranean-wide tradition of concealed maritime infrastructure. It could equally mean that similar problems, controlling harbour access, managing water supply, protecting cargo from weather and enemies, produce similar solutions in different places without any direct connection between them. Convergent engineering under similar constraints is not the same as a network, and the leap from the former to the latter requires evidence that is currently missing. So where does that leave the mystery? Genuinely open. Not comfortably open in the way that a puzzle is open when all the pieces are on the table, but open in the more unsettling sense that the pieces currently visible suggest a much larger picture, while the gaps remain large enough to contain fundamentally different interpretations. The evidence is sufficient to make the question of a broader pattern worth investigating seriously. It is not yet sufficient to settle it. What the convergence of Eupalinos, Taposiris Magna, Caesarea, and Aegina does establish, beyond reasonable doubt, is that the ancient Mediterranean world had both the engineering capacity and the cultural inclination to build infrastructure that was, in some meaningful sense, hidden, below the waterline, below the ground, or behind controlled access points that ordinary travellers and ordinary records would never penetrate. Whether that constitutes a tradition, a network, or a series of parallel responses to parallel problems is the question that the next generation of underwater survey work will have to answer. The tools to look are now in place. The sites are there, waiting beneath water that has kept its secrets for 2,000 years. The previous section laid out the strongest possible case for a wider pattern, and then the reasons to be cautious about it. Both the case and the caution rest on the same foundation: incomplete information. So it is worth being precise about exactly what we do not know, because the shape of the ignorance matters as much as the shape of the evidence. Start with dating, because it is the problem that underlies almost every other uncertainty. The Taposiris Magna tunnel aqueduct is 1,305 metres long, partially submerged, and contains wall inscriptions that are still under analysis. The current working interpretation places it in the Greco-Roman period, treating it as a replica of the Eupalinus tradition, a deliberate engineering echo of a 6th century BC Greek original, built perhaps 4 or 5 centuries later. But that interpretation depends on stylistic comparison and inscription readings that have not yet been published in final form. If the epigraphy comes back with a date in the early Ptolemaic period, rather than the later Greco-Roman phase, the entire sequencing of the tradition shifts. A structure that now looks like a late echo might turn out to be an early innovation. The Eupalinos parallel might weaken, or a different line of influence might emerge connecting Ptolemaic Egypt to traditions that predate the Greek precedent. A single inscription, properly deciphered and dated, could rewrite the intellectual genealogy of Mediterranean tunnel engineering in ways that current scholarship is not positioned to anticipate. The function question is equally unresolved, and it is not a question with a simple binary answer. The debate over whether the Taposiris Magna structure is an aqueduct, a harbour access passage, or a clandestine cargo route is not primarily a debate about what the engineers intended. It is a debate about what the structure was used for at different points in its history, because there is no reason to assume a single function persisted across centuries without modification. An aqueduct serving a coastal settlement could, under changed political or military circumstances, be repurposed as a covert access point. A harbour passage designed for vessel movement might be adapted for water management after a harbour silts or shifts. The inscriptions on the tunnel walls might resolve this, or they might describe only one phase. What physical archaeology can add, and has not yet added, is evidence of use, cargo residues, anchor-wear patterns on the tunnel walls, tool marks consistent with repeated vessel passage, organic material from rope or sail fabric that could be radiocarbon dated. None of that systematic physical analysis has been completed and published. Until it is, function remains inference rather than evidence. At Caesarea, the unresolved questions are different in character, but similar in consequence. The harbour's entrance channel sits at depths of 6 to 9 metres, and the breakwaters, roughly 250 metres on the northern side, around 650 metres on the southern, have now been mapped with sufficient resolution to produce detailed 3-dimensional models from the 2025 multimodal survey work. But the construction phases of those two seawalls are still debated. If the northern and southern breakwaters were built in different periods, perhaps separated by decades or by major reconstruction following storm damage, then the harbour's geometry at any given historical moment may have been substantially different from what the combined physical record suggests today. Navigability estimates depend on knowing original water depths, and water depths depend on understanding relative sea level change at this specific site across the relevant centuries, a calculation that requires integrating geophysical data with GIS-based sea level modelling in ways that have not yet been done for Caesarea at the resolution the site now demands. The scale question cuts across both sites. Does the Taposiris Magna system extend farther offshore than the surveyed 1.3 kilometre segment? Sub-bottom profiling along the coastal shelf west of Alexandria has not been conducted comprehensively enough to answer that. There may be extensions, branching passages, or connected chambers below the current seabed surface that no diver or ROV has yet reached. Similarly, the high-resolution mapping of Caesarea's harbour entrance covers a defined study area. It does not cover the full extent of the ancient harbour complex or its landward connections. Both surveys are, in a meaningful sense, partial looks at larger systems whose full dimensions remain unknown. Then there is the classification problem, which refuses to go away no matter how many times scholars return to it. Whether collapsed breakwater sections count as tunnels, whether an aqueduct that passes through a coastal zone and enters the seabed qualifies as a submarine passage, whether natural channels modified by human engineering belong in the same analytical category as purpose-built underground corridors. These are not simply definitional arguments. They determine which sites get compared to which other sites, which ancient literary descriptions get matched to which physical remains, and ultimately whether the broader pattern holds together as a unified phenomenon or fragments into a collection of loosely related engineering solutions. Rigorous classification standards, applied consistently across the Mediterranean evidence, would do more to clarify the debate than any single new discovery short of an explicit inscription. And inscriptions bring us to what discoveries would most change things in the years ahead. The highest value find would be a deciphered text at Taposiris Magna, naming a ruler, a date, and a purpose. Something on the order of an explicit dedicatory inscription commissioning an aqueduct for a specific settlement, or alternatively a military record describing the passage as a protected supply route. Either result would resolve the two oldest debates about the site simultaneously. Short of that, systematic magnetic surveys and deep sub-bottom sonar along the Egyptian coastline could reveal whether the Taposiris structure connects to wider canal networks, or whether comparable tunnel systems exist at other Ptolemaic harbour sites that have not yet been examined with modern technology. The Mediterranean coast of North Africa remains extraordinarily undersurveyed relative to the density of ancient occupation it supported. What wider survey work is likely to show, and what the pattern of recent discoveries strongly implies without yet proving, is that the Mediterranean basin holds far more engineered underwater infrastructure than the evidence currently confirms. Every site that has been examined with high-resolution multimodal technology in the last decade has produced surprises. Caesarea yielded structural detail that previous surveys had missed entirely. Taposiris Magna produced a kilometre-long submerged system that scholars had not suspected before divers entered it in 2022. The archaeology of the ancient Mediterranean was conducted for most of its history in conditions that simply could not see below the waterline. What is now technically possible, photogrammetry, multi-beam sonar, sub-bottom profiling, ROV access to depth that exclude divers, has only been systematically applied to a handful of priority sites. The implication is not that hidden tunnels are everywhere. It is that we do not yet have the data to know where they are not. This is the edge where the investigation stands. The questions of dating, function, navigability, scale, and classification are not loose ends waiting to be tidied. They are the active frontier of a field that is only now acquiring the tools to address them. New inscriptions could revise the chronology. Deeper surveys could extend the known architecture. Additional mapped sites could consolidate the pattern or undermine it. What separates the current moment from decades of speculation is not that the answers are close. It is that the means to reach them finally exist. And that distinction matters, because it is also the distinction that separates mystery from myth. Myth fills silence with story. Mystery maps the silence precisely, marks what is known at its edges, and waits for evidence to move the boundary. The underwater Mediterranean is not a place of myth in that sense, not anymore. It is a place of documented but incomplete knowledge, where the questions are now sharp enough to be answered, and where the sea still holds more than it has given up. That diver who first pushed into the submerged passage at Taposiris Magna did not find a clean answer. What the investigation since then has produced is something more durable than a clean answer. A set of precisely bounded claims, a map of what is solid and what is still shifting beneath the surface. Here is what the evidence actually supports. At Taposiris Magna, a tunnel aqueduct 1,305 metres long runs from Lake Maritima toward the Mediterranean, and part of that structure now sits on the seabed. Divers first visualised it between 2022 and 2026. It is a Greco-Roman engineering achievement consciously built in the tradition of the Eupalinos tunnel, the 6th century BC Greek passage that demonstrated stone-cut underground waterways could survive centuries of use. The Taposiris system is longer than its Greek predecessor, more ambitious in its coastal geometry, and at least partially submerged in a way that makes it uniquely significant. That much is documented. What is not yet resolved is whether it functioned primarily as an aqueduct serving a coastal settlement, as a protected access route for vessels or cargo, or as both at different points in its history. Inscriptions on the tunnel walls are still under analysis. Until that analysis is published, function remains a well-reasoned inference rather than a confirmed fact. At Caesarea, the Roman harbour of Sebastos has been mapped with a precision that was not possible before the 2025 multimodal remote sensing surveys. Photogrammetry, multi-beam sonar and sub-bottom profiling have produced three-dimensional models showing an entrance channel 6 to 9 metres deep. Breakwaters whose stone volume can now be measured to the cubic metre, and a structural layout that would have accommodated significant ancient vessel traffic. Josephus, writing in the 1st century, described subterranean vaults beneath the harbour that ran obliquely and carried water out toward the sea. That ancient description now has a physical context detailed enough to be taken seriously as a reference to real infrastructure rather than literary embellishment. Whether those vaults constitute tunnels in the strict engineering sense, or collapsed harbour installations that were later described in exaggerated terms, remains a question that the classification debate has not fully settled. The ancient writers, Strabo, Pliny, Josephus, are consistent in one respect. They treated concealed maritime infrastructure as a known feature of the harbour world they were describing. They do not treat it as exceptional. That rhetorical casualness is itself a form of evidence. It suggests that hidden passages, protected access channels and subterranean water management systems were familiar enough to Mediterranean port engineering that a 1st century historian could mention them without pausing to explain what they were. That is not proof of a continent-spanning network of secret tunnels. It is evidence that the engineering tradition behind such structures was sufficiently established to appear in mainstream historical accounts without ceremony. What remains unproven is the part that is also the most compelling, the possibility that the Taposiris tunnel connects directly to inland storage or ceremonial space. The Cleopatra hypothesis, the cargo route interpretation, the idea of a passage designed to move something valuable in conditions of deliberate secrecy. These are plausible inferences built on real architecture and genuine historical context. They are not confirmed. The physical evidence for covert function, cargo residues, anchor wear patterns, organic material from vessel passage, has not been recovered and published. The hypothesis is alive, it is intellectually serious, and it is unproven. New survey technology means the pace of discovery is not slowing. Every site subjected to high-resolution multimodal analysis in the last decade has produced architecture that earlier surveys missed. The coast of North Africa remains extraordinarily under-examined relative to the density of ancient ports and harbours that once operated along it. Sub-bottom profiling west of Alexandria has not been conducted at the scale the Taposiris discovery now justifies. Comparable tunnel systems may exist at other Ptolemaic harbour sites that no diver has yet entered. So the investigation that began with one diver in one submerged passage has not closed. It has expanded the question. The Mediterranean is not a place of settled maps and catalogued ruins. It is a working archive, incompletely read, still yielding documents in stone and silt that can revise what the ancient world understood about moving people, water, and goods through and beneath the sea. The roots are still down there. Some of them we are only now learning to see.